The last section in Unit 10 is going to review the ideas that we've talked about in sections 1, 2, and 3, and also going to introduce this idea, computing the volume of composite solids. So we'll talk about what composite solids are in just a second, but we want to make sure that we've got these formulas memorized. Now, there is no test on this unit, but there is a quiz, so we've only got these 3 volume formulas that we've memorized and come to understand. So you need to make sure you've got those memorized for the quiz. There's not going to be a cheat sheet or anything like that, and you can be guaranteed you're going to see problems like this on the end of the year test, because these are just classic. So the volume of a cylinder. So first of all, a cylinder looks like this. Now that's a crappy drawing of a cylinder, but you get the idea. And the volume formula is the area of the base, so that's going to be pi r squared times how tall it is. So the volume of a cylinder is pi r squared h. And a cone is very similar to a cylinder, except for we've got this kind of triangular cross section, and then we've got the front that looks like this. I'll put a dotted circle for the backside. The height comes down straight to the center and then over to here. So the volume formula is, all we have to do is put a constant in front of it, 1/3 pi r squared h, and there's the formula for the volume of a cone. It's exactly 1/3 of the volume of a cylinder that has the same dimensions. So here we need a radius. We need to know what that circular dimension is, center to the edge, and then we also need to know what the height is. Here we need to know the radius, the center to the edge, and the height. Same type of problems here. This has a 1/3 in front of it, but if we're dealing with a sphere, so a sphere was kind of cool. Okay, sphere's just a ball shape. The volume is 4/3 pi r cubed. The only thing that we need to know on this one is what is the radius. That tells us everything we need to know to find the volume of a sphere. So let's take a look at this picture right here. And we've got some story problems and we've got some pictures. It does say round to the nearest hundredth. On example 1, so we've got a cone that sits on top of a hemisphere. So let's break this up. We're basically going to figure out what's the volume of the cone, and then we're going to add that to the volume of the hemisphere. So let's think about how we could do that. Well, the volume of a cone, the formula here is going to be 1/3 pi r squared h. So we need to know the radius and the height there. And the volume here, because this is a hemisphere, it's going to be half of a sphere. So that's going to be 1/2 of 4/3 pi r cubed. Now if you wanted to, we could shorten this up and we could just do a 2/3 right here. That would be just fine. So I'm going to go ahead and write down 2/3 pi r cubed. We still need to know what the radius is though on this one. So let's take a look. Can we transfer some information over here so that we can get the dimensions that we need? Well, the radius on this one is 39. There's no doubt about that one. We do need to know how tall it is. Now that might be a little bit trickier. So let's take a look here. We need to know what the height is. Let's leave this for a second and let's come down here. The radius on this one is also 39, so we've got that part figured out. So we have everything that we need for this one. So we could actually do 2/3 pi and then 39 cubed, and we'd have our hemisphere. We'd be all set with that. Now, the trick to figuring out how tall this one is to recognize if I swing this radius around, no matter where it goes in this hemisphere, it's still going to be 39 feet. So the trick is to do this. Let's drop it straight down here and let's say that's 39 feet. Well, if that is 39 feet, and from top to bottom, from the tip of the cone down to the bottom of the hemisphere is 81 feet, then this piece right here ought to be 81 minus 39. So let's figure out what that is. So I'll bring up the calculator and we'll do 81 minus 39. So we end up with 42. So this right here, that height is 42. So let's go ahead and write 42 here. So now we've got this formula. This is going to be 1/3 pi. The radius is still 39, so we'll do 39 squared, and then the height is 42. Okay, now I'm going to put my answer over here. I'm going to put a big circle right here for the answer, and right now I'm going to say, hey, this is a volume, so this is going to be feet cubed. Okay, so let's get our answer to the 2 pieces right here. So I'm going to slide this over. So we're going to get 1/3 and then pi. Whoops, hit the right button here. Pi, and then parentheses. Whoops. Got to do a set of parentheses here. 39, and we're going to square that. So we hit square, do the parentheses, and then we get a 42. So 1/3 pi, 39 squared times 42. So we're going to go ahead and hit enter. So 66,897.073. So that is not going to allow us to round up. So 66,897.07. 66,897.07, and I always like to double check and make sure because this disappears off the screen. Okay, so we're in good shape there. We've got that one. And then the other one, we're going to type in 2/3, and then we'll do the pi, and then we're going to do 39 cubed. So 39, raise that to the third power. Didn't use any parentheses on this one, but that's okay. So we get 124, 237.42. That 3 is not enough. Okay, so this is going to be 124, 237.42. 124, 237.42. Let me bring this up again. I'm going to put a dotted circle around that and a dotted circle around that. Bring the calculator up. Let me just make sure that I wrote this down right. Looks good. Now we're just going to add those two together. So I'm going to clear this off, and we're going to do 66,897.07, and then we're going to add 124, 237.42. Okay, so I've got the 124, 237.42. And again, just like to double check here, make sure that we've got that in there right. We're looking for 66,897.07. This calculator takes a little while to kind of scroll back here. There's our 66,897.07. So we're all set to go. We're going to hit enter, and we get 191, 131.49. So 191, 134.49. 191, 134.49. And bring the calculator back, just double check and make sure I got that written down correctly. I did. So there's our answer. So this is a composite solid. It's basically made up of a couple of different shapes. So we've got this cone on the top, and then we've got the hemisphere on the bottom. We come up with a formula for each one of them, and I kind of like drawing these separate pictures and then going through and figuring it out. I think that's a pretty good idea. Okay, let's come down here. Now we've got a story problem. Let's take a look at that one. It says, the oil drilling platform called the Stratford B is located off the coast of Norway in the North Sea. The base of the platform is made up of 24 concrete cylinders or cells. If the cells have a 75-foot diameter and a height of 210 feet, what is the total volume of the storage cells? So what we've got here is we've got this platform out in the North Sea, and it's got a whole bunch of cylinders that come down and support it. So they would come down like this, whole bunch of them like that. There's 24 of them, and they're all exactly the same. So the platform stays above the water, and this comes down and hits the seafloor down below. So here's what we've got. We've got cylinders that look like this. Okay, and it says they are 75 feet in diameter. So we're going to divide that by 2. So let's take 75 and divide by 2. You might know what this is, 37.5. So that means the radius is 37.5 feet, and they're 210 feet tall. So the height is 210 feet. Okay, so they're cylinders, so the volume formula for a cylinder is pi r squared h. We don't have any fractions or anything like that. So the volume is going to be pi, and then it's going to be the radius, 37.5 squared, and then times the height of 210. Now we could type this in and then kind of compute what our answer is from there, but there are a couple things that we want to keep track of. First of all, this is measured in feet, so this is going to be cubic feet. So I'm going to write down cubic feet, and we're going to keep in mind this is one cell, and there are 24 concrete cells altogether. So what we're going to do is we're going to multiply this by 24. So I'm going to put a 24 on the end there. So let's go ahead and type this in and see what we get. I do think if you write it down this way, it's going to be a lot easier than typing this in separately and then multiplying them after the fact. So we're going to have our pi, our radius squared, 37.5, and we're going to square that, so close the parentheses, times 210. That would give us the volume of one of the cells. Now we times it by 24 to get all of them, and we end up with this gigantic number right here. Okay, so good thing we've got the feet cubed here, and it's only to the hundredths place anyway, so we don't have to do any rounding. So this would be, wow, 22,266,037.93 cubic feet. So let's see. 2226, 2226, 6037.93, 6037.93. So we'll go through and we'll put some commas in here so it's easier to read. So there we go. So 22,266,037.93 cubic feet. All right, huge volume there. Okay, that's a gigantic platform there. Okay, and then the last one in the notes says this: the first ice cream cone was made at the World's Fair in St. Louis in 1904 when an ice cream seller ran out of cups. Suppose the sugar cone for the ice cream is 10 centimeters deep and has a diameter of 4 centimeters. A scoop of ice cream with a diameter 4 centimeters rests on top of the cone. If all the ice cream melts into the cone, will the cone overflow? Okay, that's an interesting question. So here's the deal. He ran out of cups, so he made a sugar cone. So a sugar cone is one of those that you've probably had one of those. It's shaped like this. It doesn't have a flat bottom, and we've got this sphere of ice cream sitting in there like this. Okay, so in fact I'll draw this one dotted like that. Okay, so we've got the ice cream, a nice ball of ice cream sitting inside that cone, and the question here is, we've got the dimensions and stuff like that, but it says if all the ice cream melts, so say somebody sits there, they get distracted or something, it melts, would it overflow? Okay, so what we're going to do here is we're going to compare the volume of that sphere of ice cream with the volume of that sugar cone. Okay, so this has a diameter of 4 centimeters, so that means the radius is 2 centimeters. The radius on this is also 2 centimeters, and it says the height is 10. Okay, 10 centimeters. So let's compare these. The volume formula here would be 4/3 pi r cubed. Whoops, pi r cubed, so 2 cubed. And the volume formula here is 1/3 pi r squared, so 2 squared times the height of 10. Okay, so this cone is sticking up, or the ice cream is sticking up above the cone a little bit, but when it melts in there, the question here is it going to fill it up? So let's check and see which volume is greater. If the cone has enough volume to hold the ice cream, then it's not going to overflow. But if the volume of the cone is smaller than the volume of the ice cream, then it's going to overflow. It's not all going to fit in there. So let's see what we've got for answers here. So I'm going to slide this over so we can see them both at once. So I'm going to clear this off and we get this. 4/3 and then the pi. And we're doing 2 cubed. So raise that to the 3rd power. Hop over here. So we get 33.51. So 33.51. 33.51, that's cubic centimeters. Okay, so we've got that answer. That's how much ice cream we've got. And then let's type the other one in here. So this is going to be 1/3, so 1 divided by 3. Here's our pi. And then we're going to do, let's see, 2 squared. Okay, so 2 squared, close the parentheses, and then we multiply it by 10. So we've got that typed in there the right way. So we're going to hit enter, and we end up with 41.887, so that would be 89. So 41.89, and that also would be centimeters cubed. Okay, all right, so will it overflow? All right, so the answer to that is, let's see, this is the volume of ice cream, so this is ice cream, and this is the cone. So because the cone has more volume than the ice cream, no, comma, it will not overflow. Okay, and here's our work to support that answer. Okay, let's take a quick look at some of the problems from the assignment. So I'm going to switch over here. You've got some that are just a review of the formulas. So you've got some cylinders, you've got some cones, down below we've got some spheres here. Again, you're going to want to pay attention to whether or not they give you the radius or the diameter. And if I take a look at this one right here, take a look at number 8. You'll notice that the shape is made up of 2 cylinders. Okay, it looks like this one's getting a little bit bigger, and then a hemisphere. So we're basically going to add these together. So we're going to find that volume, add it to that volume, and add it to that volume. So we've got to figure this one out right here. So you'll notice that this says radius. So the radius on this one is 7, and you'll notice that it's a sphere. So the formula for this would be 4/3 pi r cubed. So we've got the radius for that one right here. Now notice this one says diameter. They didn't give you any dotted lines here. They're just telling you what they are. So the diameter on this one is 10. That means, sorry, the diameter is 20, so that means the radius is 10. All right, and these are all in inches, and then on this one right here it gives you the radius. So on this one the radius is 14. So those are the numbers that you're going to type in, and again the volume formula on this middle one is going to be 4/3 pi r cubed, but on this one, remember, the whole thing would be 4/3 pi r cubed, but we only want half of that. So if we do half, that's going to change this to a 2. So that's going to be 2/3 pi r cubed. So this is a hemisphere. Hemisphere. Okay? All right, so keep that in mind. Now I'm going to flip the page over. You'll notice that we've got a cone sitting up on top of a cylinder. We've got a cone and another cone below, but they do have different dimensions here. Think about what shapes you could use to put a pencil together, what composite shapes. So we've got cones, spheres, and cylinders. Hoping you can figure out what two those are. There's a hint on number 11. It says the cylinder is hollow. So basically we're going to take the big one and then we're going to subtract whatever the volume would be for the small one. And then let me slide down here. This one has a cake. We've got some descriptions on these other ones, but on this one it has a cake. So we've got a cylinder on the top, cylinder in the middle, and a cylinder on the bottom. So you're going to find all of those and then just add those up. Okay, make sure you're paying attention to whether or not they give you a radius or a diameter. If you need to, draw a picture. This one's about a teepee. This is about an igloo, so that would be a hemisphere. So make sure you're drawing pictures for these that don't have pictures, and good luck on the assignment. Remember, there's no test for this unit, so no practice test or anything. There is a quiz though, and you've got to have the formulas memorized. So good luck.